Hello, welcome to Engineering Made Easy. This is Lalit Vasist. In the previous lecture, we have seen what is pulse amplitude modulation (PAM) and pulse width modulation (PWM). So now it's time to understand the concept of pulse position modulation (PPM). Pulse position modulation is a type of pulse time modulation. Pulse time modulation is of two types, PWM and PPM. So let's write this categorization. The pulse time modulation. As I said, that this pulse time modulation is of two types, pulse width modulation. It is also known as pulse duration modulation. Pulse duration modulation. This is PWM, and in short it is known as PDM. And another category is pulse position modulation. Pulse position modulation. So in short it is known as PPM. So we will discuss this PPM in this lecture. Okay, as explained earlier in the earlier lecture, that the pulse time modulation PTM is a technique of modulation where the timing of the pulsed carrier wave is varied according to the amplitude of the modulating signal. So let's not write this because we have seen and written this definition of pulse time modulation. So in a similar way, in case of pulse position modulation too, the position of the pulses is varied on the time axis, okay, in accordance with the message signal, that is the modulating signal. The message signal and modulating signal are the same thing. So we can say PPM is nothing but a type of pulse time modulation. So let me start the discussion about PPM with its definition. So let's write the definition of pulse position modulation PPM. So what is pulse position modulation? So PPM is a modulation technique where the position of the pulsed carrier is varied according to the message signal or the modulating signal. So PPM is a modulation technique. Let me write it now. Pulse position modulation PPM is a modulation technique, modulation technique where the position of the pulsed carrier pulsed carrier is varied according to the modulating signal. Is varied according to the modulating signal. Okay, this modulating signal is also known as message signal. So this is the definition. To make the concept easy to understand, let me help you by drawing the waveform of pulse position modulation. But before drawing PPM waveform, it's worth mentioning that PPM is obtained by PWM. So first I will draw the waveform of PWM. So let's draw the waveforms. So first of all, I will draw the modulating signal, that is the message signal. This is the time axis, and here I am going to draw the modulating signal. Okay, this is the modulating signal. Modulating signal. Now I will draw the carrier wave, the pulsed carrier wave. Here it is, the time axis. This CT represents the carrier wave. Here I am drawing the carrier wave in pulse form, as we use in pulse modulation the pulse carriers. This pulse train has equal amplitude and equal spacing between the pulses. Okay, so this is the pulsed carrier. It has equal amplitude and spacing between the pulses. Okay, now it's time to draw the PWM, and we will obtain the PPM from this PWM waveform. So first to draw the PWM, the time axis. PWM means the pulse width modulation, also known as pulse duration modulation, PDM. So in the last lecture I have already discussed this PWM, what is PWM and how to obtain the waveform of pulse width modulation. So the simple thing is the how to obtain is that as the amplitude of this modulating signal increases, the width of the pulsed carrier increases, and as it comes down, the width decreases. So here it is maximum amplitude, and here it has the minimum amplitude and some intermediary widths between these maximum and minimum. So this is the maximum and here it is minimum. So let's draw it. These lines will help me in drawing it correctly. So let me first draw corresponding to these 3 points. These three have equal widths and equal amplitudes. Now here it has maximum and here it has minimum width. Okay, this is the minimum width. Here it has maximum, as has maximum amplitude and some, but all of these have equal amplitudes. These all have equal amplitudes. So now it's time to draw the pulse position modulation. Okay. So how to obtain the pulse position modulation from pulse width modulation? The time axis. Here I will draw the pulse position modulation. So in PPM, the trailing edge of the PWM is the starting point of PPM. So this is very important thing, how to draw the PPM from PWM. So it means that this point, this is the trailing edge of each pulse. Okay, this I have denoted it. So these trailing edges would be the starting point of the PPM pulse. As you can see here how it happens. Okay, this dotted line is the starting point of this PPM. As you can see here that all these PPM pulses have equal amplitude and also equal widths. The width is constant, but the thing that is varying here is the position or the distance between these pulses. As you can see here, it is maximum and here it has reduced, the spacing has reduced. Here it is more because here the maximum amplitude is there and here it is minimum. So you can write it here that this in PPM, this PPM waveform has equal amplitude and widths of pulses, but the information lies in the relative positioning on the time axis of these pulses. So by these waveforms you can easily understand that in pulse position modulation technique, the information is contained in the position of pulses on the axis. You should notice here that the amplitude and widths of each pulse is same, so neither the amplitude nor the width has any information. The information about the modulating signal, this modulating signal, is lies only in the position of the pulses. That's why it is called as pulse position modulation. So we can say here that the information lies in the position of pulses. Okay, the information lies in the position of the pulses. Clear? So let me write something about noise and power of these pulse position modulation, how the noise affects and the power requirements. Noise. Since in PPM the amplitude is constant for each pulse, therefore noise has less interference. Not only this, it is also very easy to separate noise from the signal, if any. So because of a constant amplitude, because of constant amplitude in PPM, the noise interference is very less, and also the noise can easily be separated from the signal. Okay, so this was about something about noise. So let's now discuss something about power of PPM, the power requirements. In PPM, as we have seen that the amplitude and widths remain constant, therefore the transmission power for each pulse is same. This is a big this is a big advantage of PPM, because in PAM, in in pulse amplitude modulation PAM, the transmission power varies due to change in amplitude of the pulses, while in PWM, pulse width modulation, the variation in transmission power was due to change in widths of the pulses. But here in case of PPM, the amplitude and width of each pulse is same. So as we know here that as the amplitude and width of each pulse is same. Okay, so therefore the transmission power for each pulse is same. Therefore the transmission power for each pulse is same. But in PAM and PWM, the transmission power varied because of variations in amplitude and widths respectively. Now let's discuss the synchronization concept between transmitter and receiver. So let's deal with it. What is this? Synchronization between transmitter and receiver. Synchronization between transmitter and receiver. So what is this concept? This is a big disadvantage of pulse position modulation, PPM, because in PPM synchronization between the transmitter and receiver is required, because in PPM position of each pulse is varied with the reference to the position of a reference pulse according to the instantaneous sampled value of the modulating signal. Therefore, the transmitter requires to send synchronizing pulses. This keeps the transmitter and receiver in synchronism. Got the concept? In PPM, synchronization between transmitter and receiver is required. Okay, because why it is required? Because the position of each pulse is varied with reference to the position of a reference pulse according to the instantaneous sample value of the modulating signal. So we need some synchronism mechanism between the transmitter and receiver. Okay, it is not required in case of PAM and PWM. Now I have something very interesting to tell you about pulse position modulation. In PPM, in pulse position modulation, you should know that it is very similar, the PPM is very similar to the phase modulation. How it is similar? similarity with phase modulation. Okay, what is this? Because in phase modulation, the phase of the carrier wave changes according to the instantaneous value of the modulating signal. We know this. And what is phase? That phase change is nothing but simply the shifting of the signal position on the time axis. So what is phase? Shifting of the signal position on the time axis. So this is called the phase change. This is change in phase. So therefore we can say that PPM, this pulse position modulation, is analogous to phase modulation, since in PPM also the position of the pulse is shifted on the axis according to the modulating signal. So you can say, like phase modulation in pulse position modulation 2, the position of the pulse is varied on the time axis according to the modulating signal. So this is quite analogous to the phase modulation, because in both of these the positioning of the signal varies on the time axis. So friends, this was the concept of pulse position modulation, PPM. We also learned some advantages and disadvantages of PPM here. If you want to get more such informative videos about engineering, please don't forget to subscribe my channel, Engineering Made Easy. See you tomorrow with new video lecture. Thank you. Bye bye.